So the very first problem of the contest, cost. This is a very simple problem. It tells that you eat from your college mess for the 6 days of the week, which cost you rupees X for each day. And if you go to restaurant, it costs you rupees Y. And you go to restaurants on Sunday. Like I'm keep doing it fast because I know most of you would have already solved. We just have to tell the total cost. We are being given X and Y. And what we just had to do was 6 into X because we eat from mess 6 days a week, and plus Y because we eat in mess only once. Please tell yes or no whether you have done this problem or not. Is there anybody who was not able to solve it? Please tell yes or no whether you are already done with this problem or not. I don't think anyone should be getting stuck at this problem. In case if you got stuck at this problem, then I would recommend you studying the basics first. Okay, let's go to the second problem. So in the second problem, we have been told that we went to a restaurant. Um, Restaurant or what? Yeah, restaurant. We went to a restaurant with K friends. Since it says that you went there with K friends, it means that you were 1 plus K, or maybe you can say K plus one number of people, right? You were this many people, and you got a bill of n number n rupees. You got a bill of n rupees, which had to be split among all of you. So everyone should have got this much um, contribution, right? This much contribution should have been for everyone. Initially, you were the one to pay all the money, and then your friends paid you their contribution. But what they did was they rounded down the money. So let's say if they had to pay 13.2 rupees to you, they paid only 13 rupees. If they had to pay you 13.79 rupees, then they paid only 13 rupees. So it's like the floor division of n by 1 plus k, whatever amount it was. That's what you got from one friend. Since there were k friends, so we would have got this much into k. Let's call this as cost for now, cost per person. So you gave n rupees initially, and you were being given k into cost per person, this much amount back from your friends, right? Yes or no? Is this correct or not? This is the amount of money you would have paid, right? This is the amount spent by you. Guys, please write yes or no in the chat whether you got this or not. And in case if anybody has any doubt, then feel free to ask it in chat. Okay, so if it's fine for everyone, then we can this lecture for level 1. It is common for all the levels, and it would be posted on YouTube. The recording would be posted on YouTube. So that's what we had to do in this problem. Like we had to tell about the total cost which you spent. You just initially spent n rupees and got k into the cost per person back, where this cost is the lower bound of n by 1 plus k. And someone is having his mic on, please turn it off. Okay, fine. And for finding this cost per person, you just have to say n divided by 1 plus k. In C++, if you are coding in C++, then you don't really need to explicitly mention the division. Because if this is an integer and this is an integer, then the result would also be an integer. It would be already lower floor division. So let's look at the code. Here we had multiple test cases. So first of all, we are taking the number of test cases as input. And then we have been, for every test case, taking the number of like the inputs, just first of all, taking the inputs n int k, and then defining the cost per person as n by k plus 1, and then saying that you spent n rupees and got k into cost back. So that's what the cost you had to pay to the person, and that's our answer. So should we move on to the next problem, or anybody having any doubt? Please write it in chat if you have any doubt. But for decimal value, I didn't understand what did you want to ask, but for decimal value, um, can you please write it in more detail? What is your doubt? I think you want to ask this thing, that where did we round it down? Is this your doubt? Do you want to ask where did we round it down? Yeah. Okay. So what happens in C++? I hope you studied about this. What happens in C++ is, if you are dividing an integer by an integer, then in that case, let's say you have 17 by 10. So what do you expect? Like if you are new to coding, what you would say is that you should get 1.7, but that doesn't happen in C++. If you have an integer divided by an integer, you would get only 1. Everything after the decimal point is already ignored. So we then really have to explicitly mention the lower bound thing. Sorry, not lower bound, but floor division. So I hope that your doubt is cleared. Please write yes in the chat if it is. Okay, fine. Okay, so are you asking for this line? Are you asking for this line? Yeah, okay. So this is nothing but this line which I wrote here. Initially, you spent n number of rupees, like n rupees. You gave n rupees, and you got this much amount from K friends. So you said that, hey, I spent n rupees and I got K into cost back. So this is finally the amount I got out of my pocket, right? That's what we had to output. So this is our answer. Here I have just printed it. See out that thing and endel. Okay. So let's see this test case once. In this test case, 999 and 9, where like n is 999 and k is 9. In that case, you gave initially 999 rupees and you were 10 people. So 999 by 10 is nothing but 99.9. This that everything after the decimal has to be ignored. So you just got 99 rupees per person. Now nine of your friends gave back to you this 99 contribution of theirs. So they gave you one like 891 rupees, and you had spent 999 rupees. So at last you got 108 rupees out of your pocket. So this should be the answer. And yeah, that's it. Similarly, you can check for the other test cases as well. Okay, great. So let's move on to the next problem then. The third problem is max nutrition. In this problem, we have been told that you are trying to be more healthy, and thus you decided, like you can read it out, this useless stuff. Here, the important thing is that you will eat at most one fruit of each type. So, let me tell you about the problem here. You are having n fruits. You are being given n fruits. Each fruit has a type. So, for the ith fruit, it would have a type AI and a nutrition value of BI. And we want to become healthy. So what we want to do is eat some of the fruits which we have, and we want to gain maximum nutrition. Nutrition. I hope the spelling is correct. Yeah. We want to gain the maximum nutrition value. If I eat the ith fruit, then I will get BI nutrition value. But there is a catch. I want that for every type, for like, let's say I have two fruits, fruit one with type 1, like the type of the fruit 1 is 1, and the nutrition value of the fruit 1 is, let's say, 6, and for fruit 2 the type is 1 and the nutrition value is 8. So here the catch is, for any type, let's say the type 1, I can eat only one fruit. Either I eat the fruit 1 or the fruit 2. Let's say if there is fruit 3 as well, which has a type 2 and a value of 4, I can eat the fruit 3 anyways, but only one fruit out of fruit 1 and fruit 2. I can eat only one of them. And that's what the problem says. That for every type I can eat at most one. I might not eat any fruit of that type, but at most one. And I want to gain the maximum nutrition value. So is the problem clear? Is the problem clear that what I want to do and what I'm being given?
Yes, sir. Yes.
Okay, great. Like I would recommend you guys to be more active in the chat whenever I ask whether it is clear or not. Just write yes or no. If it is clear, write yes. Otherwise, write no. It would be better in that case. So, is this clear? Just write yes or no in the chat, everyone. Okay, so I'm assuming it's clear to everyone. So, what I can do here is, like, there can be multiple ways of solving this problem. Maybe someone can think about solving it with maybe brute force, sorting, hashing. There can be multiple ways. Sorting is not a good way, but it can be solved with it. There are mainly two ways: brute force and hashing. I did it with hashing, but like it can be solved with brute force, so I would solve it with brute force right in front of you now. Let me just cut it out. Yeah. Okay. So first of all, let's just discuss about the brute force for now, and I would give you a hint about the hashing. So the thing is, I'm having um, that type. There is a constraint on the type of the fruits that it would be in the range from 1 to n. Okay. Like for the hashing code, I would show you my code and then I would write it with brute force so that everyone, even those who don't know what hashing, can solve the problem. Okay, so I think I forgot to remove the permissions. Just wait a second. Someone started writing stuff. Annotate, and I don't even know how to delete this. Okay, I don't know how to remove this. Just ignore these blue lines and let's look at here. Okay, so what we have is, we are having only n fruits, right? We are having n fruits. First of all, we have t number of test cases and the value of t is not so huge. It can be at most 100. And then we have n fruits where n is also less than equal to 100. And the different types of fruits, like the maximum possible number of types is also less than equal to n. So it would also be less than equal to 100. So like this is a very big hint. Everything is so small. So this is a very big hint that even if you solve the problem in t into n into n, even in this time complexity, it would be only 10 is the power 6 iteration. So it can be solved like that as well, right? This is a very big hint. So maybe you can try to think in that way. And let's try to think about brute force method. What do I want? I want that I don't care which fruit I pick, but um, I want to pick up the fruit of type 1 with the maximum nutrition value, right? With the maximum nutrition value only. Does this thing make sense? that if you have multiple fruits with type 1, you would pick up the fruit with the maximum nutrition value only. Let's say I had three fruits, or just look at here. If you had two fruits of the same type, one of them had the nutrition value of 6 and one of them had the nutrition value of 8. You could not pick up both of them at the same time. At max, you could pick up only one. So pick up the one with the maximum, just pick up the one with the maximum value, nutrition value. Right. Does this make sense? Yes or no in the chat? Just write yes or no in the chat. Does this make sense? Yeah, it's totally obvious that we will pick up only the one with the maximum nutrition value. So, but if I say that, hey, the value of type can range between 1 to n only, just run up a for loop for type starting from 1 going till n. And from there, just run up another loop from I equal to 0 to n minus 1 and check out for the fruit with the maximum nutrition value and its type being equal to this type. So in this way, you can just find out the fruit with the maximum nutrition value of the type. And once you have figured it out, you can just add it to your answer. Initially, you can initialize the answer with 0, find it somehow, and then say answer plus equal to whatever the max you found. Right? You can do it in this way. Guys, yes or no in the chat? Does this make sense? There are over 40 people and only two of them has been saying yes. Okay, so let's see it once again. Just the overview. We realized when we look at the problem that you want to have like for every type you want to have maximum nutrition value, right? Any fruit with the maximum nutrition value. So we said that hey, since the number of fruits is very small, the number of maximum possible types is very small, and the number of test cases is also very small. So what about just think about brute force? And then we saw that hey, I can just iterate over all the types, start from type equal to 1 to n. For that, find the fruit, find the fruit having this type, having this like the value of type being equal to this, and maximum nutrition value, or just find out that nutrition value, maximum nutrition value, and let's say it to be mx. So just add it to your answer. Just add mx to your answer like this. And in this way, you will be able to find your answer. So you had big O of t number of test cases. Then you had a loop of the number of types, which is nothing but big O of n. And then you had another loop for this of big O of n. So the overall time complexity is big O of t into n into n. All of them are 100, so the time complexity is just around 10 raised to the power 6 iterations. Will you discuss yet another array game? Yeah, I will discuss that problem also. So does this thing make sense? Does this make sense? Just write yes or no in the chat. Now, for the people who are interested in hashing, the optimization here, here is a hint. You don't really need to iterate over the array again and again. Like here we are iterating over it again and again for every iteration. If you want to optimize it with hashing, what you could do is just create something like maybe a map or even an array. Let's say I create an integer array of size n plus 1 and I iterate over this array only once. Let's say I iterate over the array as this and just say here the mx of ai. In this thing, I will store the maximum of the value which is already stored there and the maximum of vi. Like the maximum of both of these, I would store it inside this guy. And later on, I for every type, now I know about the guy with the maximum value and I can find the answer and just go off it. So let's look at the code of both of them. For the hashing, I'm not really spending up a lot of time right now because this is not really intended for the problem either. Maybe we can have 1 minute break for those who, just in case if someone got overwhelmed with the problem. Clear all points. Okay, so this got rid. Okay, can you please explain brute force method again? Okay, so let me give you an overview of the brute force method again. In the brute force method, what we did is that we said that the type of a fruit will range from 1 to n. This is being given to us that for every test case, whatever the value of n is, the type of all the fruits would be in that range. So we would just, for every type, which is going to be from 1 to n, I would traverse over all the fruits, like here, traverse over all the fruits, traverse over all fruits. Let's say I say for I equal to 0 to n minus 1 here. And then I will say that for all the fruits where if the AI is equal to type, then mx equal to maximum of mx and bi, something like this. Just store the maximum of the nutrition for the fruit you have got till now, and just do this. Like I will write the code for this in front of you. So let me show you the code for the hashing first. First of all, we are taking the inputs. Then we are saying that just take the inputs for all, like just first of all taking all the inputs, then declaring an array with name mx of size n plus 1, and then traversed over all the fruits. For every fruit, the type is ai and the nutrition value is bi. I just said that the maximum of this type is equal to the maximum of the value which already is there and the nutrition value of the current fruit. And after that, I just traverse over all the fruits. I know about the maximum nutrition value I can get from every type, and I just take it up into my answer, and like in this way, I can get my answer. In the brute force method, what we will do is instead of having something like this max array, um, instead of having this max array, we will just uh, traverse over the traverse over all the types first. Type equal to 1, 2, type is less than equal to n, type plus plus, and then have something like the maximum nutrition value you can get for this type. Sorry, right now I cannot really understand your code. It's very messy, like it's not formatted properly. You can raise up a query after the session if it's not working. Okay, so look, let's look here. First of all, I'm having a loop to go for every type of the fruits which I can have. Now for every type of fruit, I will be running, like going through all the fruits and just say that, hey, in case if the type or the type of this fruit is AI is equal to the type I'm looking for, then mx is equal to the max of mx and bi, and then just increment it to my answer, then print it. So it should work. Ideally, it should work. Okay. Okay, so should we go on to the next problem? Or does anybody have any doubt? In case if anybody has any doubts, then please ask it in chat. Or I think that we can move on to the next problem. Okay, let's move on to the next problem then. Okay, so in the next problem, this is the fourth problem. Three logicians walk into a bar. So in the problem, okay, so should I go faster? Someone is saying go faster. What do other guys think? Right now, this is I think the first PCD, so I'm just that's that's the reason why I'm going a little slower. Okay, so some are saying that the pace is good, some are saying go fast. Okay, I will increase the speed a little bit since mostly people are saying go fast. Okay, so uh, in the problem, it starts with a very famous riddle where it says that there are three logicians who go into a bar. The bartenders asks him that does everyone wants a beer? The first logician say I don't know. Second one says I don't know. Third one says yes. So this is like a very famous riddle where the candidate is being asked. Uh, the candidate is being asked that why did the first one say I don't know, second one say I said I don't know, and the third one said that yes. So try to guess it. The reason is that the first guys wanted to have a beer, but he didn't know what the other guys want or not. So that's why he did say I don't know. For the second guy again, he wanted a beer, but he didn't know what the third guy would like, whether the third guy would want or not. So that's why he said I don't know. Now for the third guy, he knew that only because the first and second guy wanted, that's why they said I don't know. In case if any one of them then want the beer, then he would have directly said no, and that's why the third guy directly said yes. um, like this is the answer behind the riddle. It's because the bartender asked, does everyone wants a beer or not? So the answer would be yes, only if all of them are really willing to get it. Even if one of them says that he doesn't want a beer, then in that case, all of them will directly say no. So we are just being asked a problem similar to this, where we are having n logicians who go into the bar. For every logician, we know whether he wants the beer or not by a binary string. Si is 1 if he wants, and Si is 0 if he doesn't want. And all the logicians only know about their own, like whether they want or not. They don't know about the string. And they are also perfect logicians, hence the extra information from hearing what the previous logicians reply. Like they will extract that information. So we just have to tell what the logician would say. Okay, so someone gave up an answer that until the first guy says no, one like all the ones who want the beer will say I don't know. And okay, so yeah, the logic is correct, which is it. Let's look at the problem here again. The problem says that there is a bar and logicians go there, and logicians go into the bar. Um, For the ith logician, if he wants the beer, Si would be equal to 1, otherwise Si would be equal to 0. This kind of string we have, like the string is telling whether the ith logician wants the beer or not. And all the logicians from 0 to n minus 1 would be asked one by one whether they want the beer or not. And all the logicians will give their answer on the basis of whether they want the beer or not and what the logicians before them have said. So just try to think, what if the first guy wants a beer? Or maybe let's think of the simplest case. Let's say n is the length of the string. So if n is equal to 1, if there is only one logician and he wants a beer, so what will he say? What do you think? What will he say? What would be the answer here? Obviously, the answer would be yes. If the logician wants a beer, and he knows that he is the only one. So when the bartender asks that whether all of them wants, he would just say yes. If he didn't want it, he would just say no. Let's say there were two of them. The first one wanted, but the second one, like for the second one, the logician right now doesn't know whether the second one wants or not. So he can't say yes since he wants it. Like right now, he don't know whether what would this guy say. So obviously he would reply, I don't know. Right. In this case, he would reply, I don't know. In case if he didn't want it, now no matter what the second guy thinks, he can directly say no. Not everyone is willing to get a beer. Right. Right. Yes or no? In the other case, let's say the first guy wanted. He said, I don't know. Now the second guy doesn't want it. So in this case, he can still say no. Even if there is even a single person who doesn't want the beer, then he can directly say no. So this thing you have to notice. And now let's say that what if the case was 1-1, where the first guy wanted, he said, I don't know. The second guy wanted a beer. Um, Now he said, like now he can see that the first guy would have wanted, only then he said, I don't know. So now he can say yes because all of them want the beer, right? So the algorithm which we can create from this is, for whatever the string we have, let's say this is a string, let's say this is a string we have, which contains many characters here. We would just go from left to right. If we get a one, like as long as we just get only ones, all of these people will say, I don't know, right? Whenever you get any zero, like even for the first time you get a zero, you will directly say no. Now, what do you think? What will this guy say? What do you think? What will this guy say? For the first three people, they said yes. They said, I don't know. For the fourth guy, he didn't want it, so he directly said no. Now, for the fifth guy, he wants a beer, but the question is, does everyone wants the beer or not? He has already seen someone who doesn't want it, so he can directly say no, and everyone is going to say no. Now, no matter what, whether they want or not, they are going to say no. So you can just create a variable. Let's say you create a variable bool equal to true, which tells whether um, you want a beer or not. In case if okay is false, if you set this okay as false, it means that the answer is just no. Like you can just maintain any variable and have any notation. I had a notation like this. You just have to maintain that whether you have got any zero till now or not. Once you get a zero, after that all um, logicians will just say no, as long as you are just having 1 1 1 again and again and you have not found any zero till now. The answer would be I don't know. And for the last guy, if you are at the last guy and you have not got any zeros till now, let's say there were four logicians and you got only ones, then the last guy will say yes. This is a problem for today's contest. Didn't you attend this? Like, why are you asking this? Okay, so is this problem clear? Like the logic clear? Okay, what about others? If it is clear, then let's look at the code. The code is pretty simple. We just take okay, so here, first of all, we are taking the number of test cases as input. Now for every test case, I have created a function void solve, and you would see me using this all the time after this, like on all the problems. I just create a function like this, in which I will write the code for every test case separately, and so that all the test cases would be independent of each other, like that. So for every test case, I'm taking the number of, like the length of the string as input and the whole string as input. I'm creating a variable bool equal to true, which is telling me that right now I'm not got any zeros till now. The situation is okay till now. In any case, whenever I get a zero, I will just make the value equal to false. And for all the logicians, for every logician, I'm just checking that, hey, if you have not received any, like if okay is false, it means that you have received someone saying no, that he doesn't want a beer. In that case, you would just say no. Otherwise, you will check if this is the last guy. Um, if okay is not false only, then it would be coming to else if, so you don't need to check if okay is true or not. It is obviously true, only then it is coming here. So if it is the last guy who wants a beer and everyone till now wanted a beer, so he can directly say yes. And otherwise, in the other cases, you will just print I don't know, and like this, and it did work. So is the problem clear? and like the code clear. Should we move on to the next problem? Uh, okay, so please tell your good name. Okay, so my name is Raghav. Um, I'm Raghav. Um, I think most of you don't know about me. I'm Raghav, candidate master in code forces, and like you would see me multiple times in TLE. We are gonna solve the first 7 problems of Division 4 and the first 5 problems of Division 2. So this was the second problem of Division 2. Yeah. So let's move on to the next problem. This is cursed indices. Now, in this problem, we have been told that we are being given an array A, which is having elements from A1 to AN of length n, and it contains positive indices, positive integers. An index I is said to be cursed if the sum of all elements before it is greater than or equal to that element. In particular, AI is like all the elements are greater than 1, so the first index is always not cursed. We can rearrange the array and we want to have minimum number of cursed indices in the rearranged array. Sorry. So the problem is we have been given an array A which has n elements. Unable to prove by greedy work, but it worked. Okay, I will show you. Yeah, I tried to pull out all unique values in term and sorted arrays. Okay. So what I did here is I took first of all we have an array A of n elements. We can rearrange this array and like after the rearrangement of the array or uh, okay, so before even the rearrangement of the array, we say that the number of uh, an index in the array is cursed in index in the array is cursed, let's say for I, if AI is less than or equal to the sum of elements before it, that is A1 plus A2 plus till A of I minus 1. If it is less than the sum of less than or equal to the sum of the elements before it, then this index is cursed. And we want to rearrange the array A so that after the rearrangement, the array will have minimum number of cursed indices. We want to accomplish this task. Fine. Is the problem clear? That what we have to do? Now, this is not a very for the first 4 problems, I was telling very slowly. Now we would go a little faster because now you are expected, if you are solving this problem, you are expected to know at least about the basics properly. So let's look at the intuitions and of the observations first. Intuitions and observations. We would go a little fast now. Just assume if the array is 2173, if this is the array, or if I had the array as 1237, would the answer be same or different for both of these different inputs? The inputs are different, but the answer would be same or different. The simple thing is the answer would be same because eventually I have to just rearrange the array in some way, and I want like it doesn't matter in which way I'm being given because I'm going to rearrange it eventually. So it's definitely better to just sort the array because sorting might help. Even if it doesn't help, it is not really making anything worse for me. You know, the constraints are not so tight that I can't sort the array. So even if it makes the time complexity and log in for nothing, then it's fine. And if sorting is not useful, then we would just not sort, right? So just assume that right now you are having a sorted input, something like this. Like this is not really having much to do with solving the problem for now, but it's always better to think of the inputs of such problems as being in the best way you can, like the most convenient way for you. So the array is sorted, let's say. Now, if after rearrangement, I have, I just take up the largest element and place it at the front, then no matter what I place them, all of these indices would definitely be cursed, right? They would definitely be cursed. Why? Why would they be cursed? Because for any element, the sum before this would definitely be greater than or equal to it, since I have already taken an element which is greater than all those, right? Not hard to understand, simple thing. Um, Basically, what I'm claiming here is I want to place I want to place the smallest possible element first. The smallest possible element first. Because placing an element which is large is not really helping me much, because only this element would be not cursed and all others would be cursed if I place the largest element first. So from here we can conclude that you want to place the smallest element first. Let's say I place one at the first place. Now, what is the smallest element which I can place right now? I can place two. I can place two. Yes, I can definitely place it. Like this is not cursed and this one is also not cursed. Now, what is the smallest element which I can place? I have two elements left, 3 and 7. I can place 3 here, but if I place 3 here, it would be cursed, right? Since it is going to be cursed, does it really matter if I place it here or at the end? Eventually, the element would be cursed. Now, the problem which could have happened is, what if I had 1, 2, 3, and 6? In that case, if I had placed 3 here and then 6 here, then this would be cursed and this would be cursed. Both of them would get cursed. Whereas if I had been placing 6 before 3, then this one would not be cursed and only this 3 would be cursed. Right? Try to think of this example. From there, we can conclude that we want to place the smallest possible element which can come here, which is basically greater than the sum till now. The smallest possible element which is greater than the sum till now. This is what I want to do. Yes or no? I think that this one should be pretty intuitive right now, right? We have only talked about the intuitions. We have not went into the implementation right now. Just tell me whether the logic is clear or not. The way we came to think about this stuff, is it clear or not? Come on, guys. There are 35 people in the meet, and only two of them have been replying. That's not good. Okay, so it's clear for everyone. You guys were not just speaking. Okay. So now what to do? I would definitely want to first of all sort the array because it is not really causing any trouble for me. After sorting it, I want to create something like an answer array, since I guess I have to print the answer at the end. Yeah, I have to print the answer array at the end. So let's create an answer array in which I would place the smallest possible element which I can place here. Let's say I placed a1, small a1. After that, I want to place a2 such that a2 is greater than a1. Then I want to place a3 such that a3 is greater than a1 plus a2. The smallest possible value I can place here. The smallest possible value uh, which is greater than a1 plus a2. Then for a4, I want it to be the smallest possible value greater than a1 plus a2 plus a3. Let's say after that, there is no such value which is greater than a1 plus a2 plus a3 plus a4. In that case, now it doesn't matter in what way I place these elements because all of these would be cursed and these are not. So if I've created an array like this, let's say this is my answer array, I can just simply say that, hey, the number of cursed elements would be n minus answer dot size After that, just print out these elements and just print out the remaining elements, right? We can just do this. Like, this is the way we can implement it. For finding out the elements just greater than that, just greater than a1 or just greater than a1 plus a2, either you can use binary search or use the inbuilt upper bound function to find those values. If the numbers are 1, 2, 3, 7, then when we come to 7, the sum is 7, so the number is 53. So it won't be uh, the thing which you are saying in this case. If we have 1, 2, 3, 7 like this, um, even right now we are having only one cursed element. So, like, this is passing in this case. We are when we are just writing it in sorted way, but writing it as 1, 2, 7, 3 is definitely better. Like, if you write it in this way, the way I'm saying, we are not having less, we are not having more number of cursed elements. Like, just look at it again. So, like, you can see that the method is not failing here either. Priority queue. Yeah, you can like, you can take use of priority queue also, but using priority queue is not really the best thing you can do here. A better way which I felt is using multi-set. If you don't know about multi-set, don't worry. I would suggest you to study about it and then look for using it. This is like, you can do it with binary search and upper bound also. It would require you to create some vectors and store data from here and there with vectors. But with multi-set, it would be very easy. With multi-set, what I did is just stored up everything inside a multi-set first. So let's say I have 1, 2, 3, and 7. I just stored all of these elements inside a multi-set. After that, I had an answer array, and I created a variable named as sum in which I'm storing the sum. So initially the sum is 0 and the answer array is empty. So I just looked up in the multi-set. I named the multi-set as st. So I just run up and a function in multi-set st.upperBound sum. This is a function which would just return me the element just greater than whatever parameter I pass. So initially sum is 0. So the first element which is just greater than 0 is 1 here. So I got 1. I just pushed it here, incremented the sum by 1. Then I looked for element just greater than 1. I found this 2 here. I just like, added it to my answer, incremented it in my sum, and now again search for the element just greater than 3. The element just greater than 3 is 7. So just add it to my answer, increment the sum. Now the sum is 10. And yeah, one more thing, remove these elements from the set. Once you add it to your answer, remove it from the set. Now you have 10. When you try to find an element which is just greater than 10, you won't find it in the set. If you don't find any element greater than that, in that case, now all the elements in this set which are still in the set would be cursed. So this is the minimum number of elements you would have cursed. Just print it, and then just print down the answer array, which is nothing but 1, 2, 7, and then all the elements in the multi-set. Now it doesn't really matter in which order you set the elements from the multi-set, though it would come in the sorted order. These elements are not cursed and these ones are cursed. Someone wrote a long message. My approach is that we will sort the array, take two arrays, not curse and curse, initialize the sum with it. Yeah, Ashnu has written the approach of doing it with binary search and upper bound, where instead of using the set, you just have like, you just sort the initial array you have and then create two arrays, cursed and not cursed. The elements which are not cursed, you push them here, and the elements which, sorry, the elements which are not cursed, you push them here, and the elements which are cursed, you push them in the cursed array. But I think that you would have to write longer code in this. Doing it with multiset will have shorter code. So yeah, multiset will store the data in the sorted order. And I would highly suggest you to study about multiset. It's not hard. You can just understand that what it does and how, like what are the methods. You just have to remember that. It would take hardly half an hour, and it's a very useful data structure. Hardly half an hour, not even that much, and it's a very useful data structure. So I would highly recommend you to study about it. Now let's recap what we did in the problem. We first realized that taking smaller element first is useful, whereas taking larger value first is not useful. So we would try to take the smallest value first. And having a value cursed first is useless. I'm talking about the case if you take 1, 2, and after that 1, 2, if you take 3, it is not really causing you any benefit. It is just, it might cost you some trouble if you had 6 here. It would make some value which could have been not cursed as cursed. So you definitely don't want to have any cursed value first. So just combining both of these things, we decide to take the smallest possible value first, which is not cursed, which is not cursed. Like if you place it here, it won't be cursed. Cursed. Or in simple words, its sum is completely greater than the sum of the prefix you have got till now. Like the value is greater than the sum till now. So that's what we had to do. This is the high level thinking of what to do. Now for implementing it, for the part of getting the value just greater than something, it reminds us of upper bound. To keep things short, I used a multi-set. You can use a set. It's up to you. Implement it in any way you want. Um, like if you have figured out the logic, coding it should not be hard for you. Like you should be comfortable with it. Try out all the method. Try out all the methods of implementing it for practice, and we will just find out the elements which we can place at the current index and just place them and delete it from the set. And we took an example for it. If when we had 1 2 1 2 3 and 7 in as the input, or if we had 1 2 3 and 6 as the input, then the way we would place them in the answer array. So is the problem clear? Like is the logic clear? Should we move on to the code and then the next problem? If anybody has any doubt, then please ask in the chat. Okay, so let's see the code. In the code, first of all, first of all, I'm taking the number of test cases as input and running up the solve function for all the test cases. Now for every test case, I am first taking the inputs. While taking the inputs, I stored them in a multi-set. In a multi-set, the elements would be kept in sorted order, and um, there can be duplicates. Like there can be multiple values with the same value as well. There are multiple elements with the same value in the set. Then I'm declaring a variable long sum initialized by 0 and a vector int answer. Then while there are elements in the multi-set, just find the upper bound. Upper bound will return you an um, iterator. Just check if the iterator is equal to st.end. Like this is something related to set. If it is equal to st.end, it means that there is no value which is greater than the value passed in the as the parameters. In case if there is any one of them, then it won't be less. Then it won't be equal to st.end. So we will just dereference the value and increment it to our sum and push it into the answer and delete it from the multiset, keep doing it until there are values, until we can find values. And at the end, we will just print n minus answer dot st dot size, or maybe just, n minus answer dot size, or just print st dot size. These are the cursed values, the values which are still in the set, and just print that these things. That's it. That's the problem, like done. So should we move on to the next problem? I would recommend you to try out both the methods, this one and the method involving binary search, without using multiset. Okay, so let's see the next problem. Okay, this one involves some casework. In this problem, we have Alice and Bob play a game on an array of size n. Alice moves first and their turns alternate. Alice has with her another array B, initially empty. On Alice's turn, she chooses an element that remains in array A, deletes it from the array A, and appends it to array B. In Bob's turn, it just chooses an element from the array and deletes it. And this proceeds till the array A is empty. Alice must ensure that the array B must remain sorted. That is, the elements in, like, initially they have an array A. They have an array A. What will happen is, in Alice's turn, she would choose any element from the array, delete it from the array, and push it at the back of the array B. Like whatever the array B was, it will just push it to the back of it. In uh, in case when Bob has that on, it will just choose an element and delete it. Would not push it anywhere. When Alice pushes it, permutation construction. This permutation construction was like it was the problem after this. Like this yet another array problem is supposed to be a problem coming before this one. Um, though this problem got solved by more people, so that's why you might be thinking it to be the question 4, but this one is supposed to be the question 4 as much as I know. I think that yet another array game was before the permutation construction practice. Anyways, we have started this, so I will discuss this one and then this one. Don't worry, I will discuss both of them. Okay, so let's look at this. um, When Alice deletes an element from the array A and pushes it to the array B, she has to make sure one thing, that the array B is sorted. It should be sorted in non-decreasing way, which means that for any index I in the array B, the element should be greater than or equal to the element before it. This thing should be made sure. And there are two uh, sub cases, subtasks in the problem. One of them says that like we are being told about the subtask with S, whether it is 0 or 1. In case if S is 1, in that case, what Alice can do is, like initially what is happening is Alice will have a turn, then Bob will have a turn, then Alice will have a turn, then Bob will have a turn, then Alice will have a turn, and so on. If S is equal to 0, it would just go on in this order. If Alice deletes an element and pushes it to the array B, then at the end of the game, the score of Alice would be the sum of all the elements in the array B. And in case if Alice has a turn but she cannot move, she cannot perform her move, then Alice will have a score of 0, which is the worst she can have. So in S is equal to 0 case, this is how the game goes. In case if S is equal to 1, then Alice has the choice of not placing a move. Alice can just skip her move, so she would never have a score 0. Like this is what happens in the problem. If S is equal to 1, Alice has further option to skip her turn as many times as she likes. Bob cannot skip his turn though. And Ali's score is defined as follows. If she is not able to make a move at some point of time, her score would be 0 only when S is equal to 0. If S is equal to 1, then that's not the case. And otherwise, if A is empty at the end, Ali's score is the sum of the elements in the array A, array B. And Alice wants to maximize her score, Bob wants to minimize her score, and both of them are going to play optimally. We have to find Alice's score. This is the problem. Is this clear? Is the problem clear? Problem clear or not? Okay. So first of all, let's talk about the case if S is equal to 0. Obviously, S is equal to 1 is more complicated as it involves, like it gives one more choice to Alice. So solving S is equal to 0 is gonna be easier. In S is equal to 0, you see one thing, or in both of the cases, you see one thing. Li's score would be equal to the sum of elements in the array B. So Alice definitely wants to pick. Alice definitely wants to pick larger values. Bob wants to keep Alice's score minimized. So Bob wants to let her pick only small values. So Bob also wants to pick larger values. Wants to pick larger values, right? We are just going about the obvious observations. For now, these two were very obvious. And the third thing, allies don't want to have zero score. Don't want to have a score of zero. Like, like in any case, allies would never want to have a score of zero, right? Now, let's see the one thing. If there are n elements in the array, let's say n is even. Why we are talking about even a lot? Because Alice and Bob will have consecutive alternative turns. So in this case, when n is even, Alice would have a turn, Bob would have a turn, and it would happen at last. Alice would have a turn and Bob would have a turn. Basically, the last turn would be played by Bob and the first turn would be played by Alice. Both of them would have same number of turns, equal number of turns. So Alice is definitely going to have n by 2 number of elements, and Bob is also going to have n by 2 number of elements. In case when n is odd, then n Alias is going to have n plus 1 by 2 number of elements, and Bob is going to have n by 2 number of elements, or basically you can say as n by 2 plus 1 number of elements, like this. So you will see that Alias will have one extra element with her, which she would remove. So let's talk about the case of Alice like odd first. Let's take the very simple example. When n is equal to 3, let's say Alice picks up this element. First of all, like the last case, sort the array. Why sort the array? Because even if the array was sorted, the answer would remain the same. So just sort the array. Now when the array we have is sorted, if Alice picks up the second smallest element, second largest element, Alice picks this, Bob will pick this. Now Alice will have it her turn, and she would have to pick up an element which is smaller than the previous element. She cannot make this move, and thus she would have a score 0. So picking up the second largest element is going to be bad for her. And even if there were more elements, let's say if there were 5 elements, and she picked up the second element, Bob would pick the last one, she would pick this one, Bob would pick this one, and she would again be forced to pick up the smallest element, which is like smaller than the previous element she picked. So eventually, the thing is, when Alice would have picked n by 2 elements, Bob would also would have picked n by 2 elements. And if the n by 2 elements which Alice picked, like Bob would definitely pick the larger elements, the largest n by 2 elements. So if Alice has not started with the smallest element, she might not be able to pick up an element. Right. I hope you would have got some intuition of what idea I'm trying to give you. Okay, let me go a little bit. Yeah. So the thing is, in case when the number of elements are odd, you can try out multiple test cases. Obviously, when I'm telling you, I've already tried out all the test cases. That's why I know of what will happen. It's always best for Alice to pick up the smallest element. Bob will pick up the largest one. Alice will pick up the second smallest. Bob is happy because he knew that Alice will definitely pick up n by 2 plus one number of elements because she has one extra turn. But Bob managed to get Alice pick up the smallest n plus n by 2 plus one elements. So Bob is happy. Alice is also happy because she could not do anything better. Like this is the only thing she could do. If she had tried to pick up any element out greater than this, like after the middle element, then she was just getting trapped later on, right? So we see that if, like for the case when s is equal to 0, if n is odd, if n is odd, Alice will just pick up the smallest n by 2 plus 1 number of elements. What if n is even? Just try out with small cases first. What if n is 4? This is like a this is kind of a constructive algorithm problem or ad hoc problem. In this kind of problems, we just try to find patterns and do some case working like the way I'm doing right now. So here, if n is equal to 4, what you can do? Maybe you can, like the last time, you can try to think of just picking up the smallest element. Bob will pick up the largest. We will pick up the second smallest. Bob will pick up the second largest. Now Bob is happy because he constrained you to pick up only the smallest two elements. Bob is happy. But are you happy or not? So for that, just try to think what you could do. Like, could you try to pick up some better way, some better elements? What if you had tried to pick up the second smallest element first? Bob would have still picked up the largest element. Then you could have picked up the second largest, and Bob would have been forced to pick up the smallest one. So in this way, you could have picked up better pair of elements. So this is definitely better for allies, right? And you can try this for n equal to 6, n equal to 8, and so on. You will see the best thing allies can do here is just start picking up from the second smallest, third smallest, fourth smallest, and so on, as long as allies can pick up elements. This is the best way in which allies can pick up n by 2 number of elements. So does this make sense or not? Yes or no? Does this make sense or no? Okay, great. So it makes sense what we have to do for s is equal to 0 case. And yeah, I actually wrote the exact thing code for this. First of all, just sorting the array. And then if s is equal to 0, then just traverse over. Um, okay, so I wrote it in a little different way. Like instead of writing the case differently for even and odd, what I did is I just noticed one thing that hey, um, till the middle element, sorry, this is the middle. So till the middle element, you have to pick up elements, whether it like doesn't depend whether it is even or odd. You have to pick up the elements from second till the actually this point. Basically, you can just write up two for loops differently for both these cases. It's not hard to just write up two for loops. It's like very simple thing. You can do it on your own also. What I did here, since I was very lazy to write up two for loops, I just said that hey, I would run up a for loop till this point, till the index is less than equal to n by 2, starting from 1. And at the end, in case if n is odd, then I would add this value as well. And I'm adding these values for both the cases. And I think that it might look a little bit hard to understand for some people. So you can just write up two for loops. Just write up two for loops for even and odd if you feel it complicated. And then print the answer. But what if s is equal to 1? What if s is equal to 1? This one has some good idea. Here you can like, are you guys with me till now or not? First of all, tell me about this. Those who are in the meet, are you with me or not? Are you able to understand the part which I have discussed by now? Okay, great. Okay, so just see this. When s is equal to 1, again you try to make some test cases, some case work, that what if n is equal to 3? In case of n equal to 3, one thing now allies could do, one of the ways was as as it is, like just pick up the smaller two elements. But now if allies tries to pick up this element directly, Bob's pick up this one, allies is not really forced to pick up this one. She can just um, skip the turn and Bob would pick it. Though obviously it is not beneficial for allies right now, but this lets allies do this. Pick up the largest element and just skip all the turns. Right. In case of the three elements given to us were like this, 1, 2, and 7. For the case when S was 0, allies was forced to pick up the smaller two elements only. Right. Allies could have only 3. But now allies can just pick up the largest element, have 7 into her pocket, and skip all the turns, let Bob take both of these, and that's it. That's how allies can take use of the advantage she's getting now. So if you try to make up some cases, you would see if allies first of all picks up the largest value, she cannot pick up any of the values now. If she picks up the largest value, she will have only one value. If she thinks that, hey, I will pick up the largest, second largest value so that I can pick up the largest value later on, Bob would pick up the larger value and would not let allies take it. So allies would not be able to pick up any value. So obviously picking up the second largest doesn't make any sense for allies, right? It is even worse than the previous one. But allies can pick up the last third value. Bob would pick up the last value. Then allies can pick up the last second. Now allies has got these two, and these two might have a sum greater than the largest value. Similarly, when you try to make up more cases, try to see more cases, you would see another thing is allies pick up this one, Bob picks up this one, allies picks up this one, Bob picks up this one, allies picks up this one, Bob, whatever Bob picks, allies is not going to pick up anymore. And allies in this way can pick up these three values. Like initially she didn't skip anything, then she skipped one of the values and picks up two from the end. Then she skips last two values from the end and picks up three. And similarly, another pattern would be picking up four values, and there are three empty values, and whatever goes there, like money values can be there, but she would not be able to pick up any of them. And in this way, there would be it would just happen till the number of uh, elements she's skipping, let's say to be I, and the number of elements she's picking, I plus 1, exceeds n. The sum of these two exceeds n. Till that it would go on, the pattern would go on. Like this was the observing a pattern. As I discussed that in constructive algorithm problem, you have to observe patterns, find out patterns. So this is the pattern which we had to find out. We have found out a pattern. So now it's simple. You just sorted the array. Now thinking about leaving some elements from the end and then picking up elements from the end is not very easy for us. But better thing which we can do is just reverse sort the array. What do I mean by reverse sort the array? Just reverse sort it in non-increasing way. So AI would definitely be greater than or equal to AI plus 1. It would be greater than equal to the next element. Like doing this is just making the stuff a little bit easier for us to understand. So now what we can do is first consider picking up only the first value, then consider picking up the next two values, then consider picking up these three values, then consider picking up these four values, and then consider picking up these four and like one more. Consider picking for these five values like this. So maybe you can just run up a for loop for I equal to 0 to like n, and like running it till n, obviously it won't go till there. Just break it in case if I plus 1. If this thing goes greater than n, then just break it up. Now for all this loop, what we are saying is skip I of the first elements, skip first I elements, and then take the sum of next I plus 1 elements and store the maximum of that, and store the max of that into answer. Right, we can do it in this way. I hope that this makes sense. Please tell me yes or no for the people who are still in the meet. Up to length by 2 plus length mod 2, right? Okay, so you have written some formula, but I would say that I didn't really want to take any risk by talking about formula, because there I would have to take care of corner cases. So that's why I just um, ran the loop forever and did have this condition, just to be on the completely safe side, not taking any risks. Okay, so if it's clear, let's look at the code. For the case when s is equal to 1, oh yeah, by the way, in the input, we have been given s with along with the test case. We are given it along with the test case. So I took it after taking input of the test case and passed it inside the solve function. Okay, like it's not any hard deal. And here, when s is equal to 1, it would be coming to the else condition. I'm reversing it. I've already sorted it. Now just reversing it to have the largest values first. And since I have to take the sum of the elements again and again, for that I created prefix arrays. There are multiple, a bunch of ways you can do it. Maybe if you want, you can do it using segment trees as well. But prefix sum is the easiest and the simplest way here. So I am using it. Here I just run up a for loop to create like generate values in the prefix sum array. After that, I did run up that for loop I was talking about for I equal to 0 to n, having a break condition when the number of elements I'm skipping and then taking exceeds n. In that case, just break it. Otherwise, store the maximum of the sum of those I elements or I plus 1 elements into the answer, and then at the end print answer. So that's how we can do this problem. So does like, should we move on to the next problem? And are you guys able to understand the stuff I'm explaining here? In case if you are fine with it till now, if you are with me, just write cool inside the chat.
Yes, yes. I think it is solvable now
Yeah, it's
during the
now very
contest.
solvable.
Yeah.
We just had to do
Because
some case.
during the contest, I thought it was a bit hard problem.
No, it is not that hard. Like, it's solvable.
I tried the permutation one during the contest and skip it.
Okay.
So, now
For the
it's looking easy.
okay, let's look at the permutation one now. Yeah. For this problem, I didn't really got a lot of time to think, since um, I got an intuition and that intuition worked out for this. So I would explain the way I approach the problem. Like, I didn't really think a lot of casework, just got it luckily at the beginning. Okay, so Ekam has written the exact same thing which I did. Sort of, I did a sort of this thing. So in the problem, what it says is we are being given two integers n and x. We are being given two integers n and x, and we have to create a permutation of these n integers such that the first element is x. So the first element of the permutation should be x. And if we create a difference array of the permutation, um, sorry, difference array, for those who don't know about the difference array, it's nothing but, let's take an example. If you have 2, 3, 7, 4, and 6, the difference array would be 3 minus 2, that is 1, 7 minus 3, which is 4, 4 minus 7, which is minus 3, 6 minus 4, that is 2. Like this into this is the difference array, and it would have one element less than the number of elements there were initially. Sorry. So we want to construct a permutation whose first element is x. The length of the permutation should be n, and the difference array of this permutation should be a palindrome. If there are multiple solutions, you may print any of them. And if there is no solution, then print -1. That's the problem. So is the problem clear? The problem is pretty straightforward. Like at least the problem statement is pretty straightforward. Okay, fine. So in the problem, one of the intuitions I got, like uh, just after reading the problem, I went to the sample test cases part. I saw that 3 and 2, like for n equal to 3 and x is equal to 2, I can't really have any permutation where it starts with 2. Either I would have 2, 1, 3, or I will have 2, 3, 1, right? In both of them, there would be some problems because I would be getting these positions together. So it was not going to work. And in case if n is like, so my intuition here was, in case if n is odd, let's say the mid, let's say the mid element to be n plus 1 by 2. Like here it is 3 plus 1 by 2, that is 2. So x should not be equal to mid. If x is equal to mid, it doesn't really look like it would be possible to create any permutation. And the simple test cases was just giving me some confidence in this. So I just believed that my intuition should be correct. Like I just believed it in this way. And nextly, I saw the other examples in which I was having like 3, 1. So for n equal to 3, if I have x is equal to 1 or 3, then in both the cases, it would be possible to create permutation like 1 to 3 if 1 should be the first element, or 3 to 1 if uh, 3 has to be the first element. Similarly, there were test cases where you had n equal to 4 and x equal to 4. Like this is also a constructive algorithm problem where you have to find some pattern. So I didn't really focus a lot on going into logical thinking. First, I went through the intuitions I was getting. So for n equal to 4 and x is equal to 4, I observed one thing, like I already had been getting this intuition that if 4 comes first, I want to have, like if the largest element is coming first, I want to have the smallest element coming at the end. Like I just wanted to see if this pattern is going to work or not. And then for these values, just place up any value of your choice. Let's say I place 2. Then this is the second smallest value. Just place up the second largest value here on the opposite side and try to see if it would work or not. So here, like one, obviously it is working. You can see this thing that it is working here. 4, 2 minus 4 is -2. 3 minus 2 is 1, and 1 minus 3 is -2. So this is a palindrome. The method is working. And why is it working? Like why is it working? The thing is, let's say I placed 4 here and 1 here. Now, if I'm placing something like a 3 here, which is just one smaller than this, the largest element, and on the other hand, I'm placing an element which is just one greater than this element. So obviously, uh, this minus this which would be equal to this minus this. This is obviously going to happen, right? This is sort of a logical proof. Like I just logically proved it to myself in this way only, that hey, yeah, when n is even, it is definitely going to work. This was the intuition I was having, and then I logically proved it in this way, and it was working for all the test cases. So eventually, I came up with the idea that I have some n and I have some x. For taking the case when n is even, let's say n1 to be equal to n plus 1, like just instead of writing n plus 1 everywhere, I'm going to use the word n1 here. So if you have x at the first place, place n1 minus x at the end. Now place up anything here. Let's say I place 0, a0. Then place n1 minus a0 at the end. The benefit here is, here you get a0 minus x at the end. Like initially here in the difference array, you would be having a0 minus x as the first element. At the end also, you see, you are still having a0 minus x, like n1 minus x minus n1 minus a0 is nothing but a0 minus x. So you are having a palindrome here, right? In this way, you are having a palindrome here. In case if it is something like n equal to 5, when n is equal to 5 and x is equal to 3, if you have the first element as 3, here n1 is equal to 6 and n1 minus x is also equal to 3. You cannot really place 3 at the different place. Like in this case, you cannot really place up the element you want to place at the other side. So here there would be no palindrome possible. So the answer would be -1. Answer in this case would be -1, right? So I think that the intuition should be clear. I just told you in the exact same way I thought during the contest. In this exact same way, I did solve this problem. And another thing I just had as an intuition is, what value I pick of this a0 doesn't really matter as long as it is not equal to x or n1 minus x. It doesn't matter what value I pick. Similarly, for this value, it doesn't really matter. But it does matter in case if n is odd. When n is odd, you want to place the middle element, which like where x is equal to n1 minus x, that value of x, you want to place it at the middle. You want to place it at the middle. Let's call it as mid. And for the first value, it's just x, and the last value is n1 minus x. For all the other values, you just start placing them in any order and just keep placing the mirror element and so on till you are done with placing all the elements. So does this make sense? Are you with me till now or not? Please write in the chat. This was the last problem which we were going to discuss. I hope it's clear. Now the part of how did I get the intuition? In my case, I just got the intuition like randomly. One of the things which gave me the confidence for this intuition, like it didn't feel very random, is because it was working on all the test cases, and then I just logically proved it. Obviously, I didn't write it on paper to logically prove this thing. I just did it in my head. It took barely 2-3 minutes to logically prove it. Okay, so if it's clear, then let's look at the code and then end the meet. First of all, too many edge cases during a contest. Uh, for the part of edge cases, I don't think would be any. And obviously, there are not any edge cases. The solution got passed. The only edge case I was thinking of was when this middle is not at center, and the part if I just randomly place anything here and there, would it cause any trouble or not? That's the only thing I case worked. First of all, I'm taking the input and index. Then just for the purpose of not writing n one n plus 1 by 2 again and again, I just stored it inside a variable named as mid. In case if the number of elements in the array is odd and the element which I have to place at the start is the middle element, then in that case just print -1, that there is no such palindrome, there is no such permutation possible. Then since I was not really interested in writing n plus 1 again and again, I just named a variable n1. Then I created an answer array. Answer 0 is equal to x initially because that's what the problem asked us to do. And answer of n minus 1 is equal to n1 minus x. Um, like obviously it is as we discussed in our approach. Then I'm just um, putting up everything which I can still place in the permutation into a set so that I would know which elements I can place. So unless this is one of the elements which I've already placed, I'm not going to place them. Just inserting all other values. In case if n is odd, then I'm erasing the middle element and placing it in the answer array. After that, I just like pick up the smallest value from the set. Like you can pick up any value from the set, and its complement, like not a complement, but the element at the mirror position would be n1 minus val1, as we discussed in our approach here. Like just if we just do it in this way, and then putting up the values into our answer array and erasing it from the set. Just keep doing it for n by 2 iterations, and the first iteration has already been done, so starting on with I equal to 1. After that, print the answer array. That's it, simple, done. The problem is busted. So I hope you like the contest discussion, and for those who have been watching it on YouTube, please consider liking the video and subscribing to the channel if it helped. You can write it in the comment section, that whether you like the PCD or not. And if you have any suggestions, please do tell about them in comment section or fill it in the form. So thank you for attending the PCD.